In this video, let us understand what is Sulhouete coefficient. Generally, it measures the performance of clustering algorithm. It measures how similar an object is to its own cluster compared to other clusters. Now, we need to understand two things here. One is a cohesion and the other thing is a separation. Now, let us talk about cohesion. Cohesion is a measure of distance from one point to the other points within the same cluster. What does it mean? Suppose if I have a cluster here and I have got all my data points scattered over here in this cluster. Now here I'm trying to find the distances between this point to this point and this point to this point. Now the average of all these distances will be given by a point called A of I. Now this is about cohesion. Now let us talk about separation. Now if I have another cluster and my data points got scattered in this cluster. Now here I would like to find the distance from this point to these points in these clusters. Now the average of all these points will be given as average distance of all these points will be given as B of I. My Sulhouete coefficient equation will be now S is equal to B of I minus A of I. So now I'm trying to normalize this equation by using a max function. Say that max of B of I comma A of I. Now here let us understand this equation. Suppose if B of I is greater than A of I, then in that case it's going to have a big separation. These two clusters will have a big separation. And in that case, we can directly say that this model has performed very well in clustering algorithm. Suppose if B of I is lesser than A of I, suppose A of I is greater than B of I, in other words, that means here some of the points from A of I got mixed with the points in B of I. That means it's not performed well here and it gives a bad performance clustering algorithm model. So that is the case when A of I is having more than B of I. Now let us understand another scenario here. When B of I is equal to A of I, that means it's equal to 0, right? In that case, we are going to have these two clusters. It's going to get joined here. This cluster is going to, there's no distance between this cluster and this cluster. And whatever the data points uh, that stands here, it's not going to judge whether it belongs to the cluster cluster A or a cluster B. So in that case, we need to investigate further and find out the solution where this data point is going to get fall. So this is about the equation called Sulhouete coefficient. Now it generally has two things here. It'll be in the range of +1 to -1. All right. So if a value is closer to +1, that means it's giving a better performance. If it is not closer to 1, if it is going closer to -1, it is giving a bad performance. All right. Now, with the help of Sulhouete coefficient, we can also find the optimum value of k here. Now here you have seen this k value. Here you have seen the k values. When k is equal to 3, we have this graph, and when k is equal to 4, we have this graph, right? Now, by looking at these graphs, you can easily find out that, just a moment, so here you can easily find out that we have we have only one negative value for k is equal to 3, but for k is equal to 4, we have many negative values. And the other observation you can find it out from here is we have large number of positive values when k is equal to 3. So definitely with the value of k is equal to 3 is performing better. So our best optimal point is when k is equal to 3 has a best optimal point. All right, this is it in this video. I'll see you in the next one. Thank you for watching.